So hi everyone, good morning. My name is Gábor Manhertz and I am a solution architect at VINcoSIM, responsible for R&D digitalization. And today I will tell some words you about the web-based simulation of VINcoSIM power modules in your application. I will show you the new VINcoSIM simulation environment. Our agenda looks like the following. So I will start with the product characterization, followed by the topology and product modeling. And I will show you examples how you can evaluate faster products with our tool and evaluate special requirements. Then I will close my presentation with remarks and the summary section. So let's start with the product characterization. At VINcoSIM, we measure and characterize each and every of our product for validating the design and the manufacturing process. And with this, we are preparing data and the characteristics for our final data sheet and the VINcoSIM simulation environment. We took digitalization initiatives here in the lab, so we created the general measurement independent data model, which has a common basis for static, dynamic, and thermal characterization. This is what we are calling VINcoSIM electric blocks. These are full, flexible digital representations of the measurements. Additionally, our measurements are fully traceable, so from the beginning, by defining the measurement until the execution and the results, we can trace back everything. And we measure and store the raw measured physical signals in a centralized database. With this, we achieve that this data is easy to access and easy to integrate and connect to any kind of our internal or external tools like the VINcoSIM. Here you can see some examples from our lab. So this is our custom-built, flexible, high-power double pulse tester. And we have off-the-shelf components, of course, for static and thermal characterization. You see some example measurements from a product and the evaluated results in the simulation environment, the dynamic characteristics. How these characteristics will put into the model, so I will talk you through the product milling. We separated into different stages the modeling, so we defined simulation models. We are calling them functional topologies. Here you can see an AMPFC and a six-pack model. From these blocks, we can construct a complete subtopology like a three-phase AMPFC and the six-pack additionally. And if we define the BOM list, the mechanical construction, the outline, and everything what is required for manufacturing, we get the end product. Finally, from this, we define the reference designators, we define the chips, and we connect the required characteristics for it. And from this, we can export the final data sheet and the simulation model as well. Let's talk a little bit more about the functional topology modeling, because this is the core of our simulation environment. We define the general description, so a topology-independent description for it. The model elements are the general functional positions. So for in the AMPFC, you see it by numbers on the slide. We define different operation modes, modulation methods analytically in the background. We describe the duty cycle and the conduction curves. And also the input and the output waveforms. From that, we highlight which are the excitation waveforms for our simulation. Here you can see an example. So the AMPFC example has 7 positions. These are identified. And one description for the AMPFC is the PFC operation mode, the continuous conduction modulation method, waveforms, and the duty cycle. And we have a loss calculation table, which will define where and how the static and the dynamic losses have to be calculated. This is what you can see here. So we split, every operation method has its independent loss calculation table. we define in the table which components are working in which section of the period. You can see the AMPFC, this is in the positive, and this is the negative connection routes on it. And in the table, we highlight what are the static loss and where dynamic losses occurs in the operation of this topology. This is independent from the number of sections. So for example, in case of inverters, we define 4 or more sections, and independent from the number of the functional positions inside one topology. So how we can use these models and the results to evaluate speed and flexibility of our products? Here will be a video representing how our simulation environment works. So it's completely integrated into our website. So we are using our website search to perform simulations. We are looking for a product, in this case, the previous example for the three-phase AMPFC with a six-pack. First, you will get a fast overview of the products. These are the same data what we have on the website and in the data sheet. Then we can set fast the simulation inputs. Some helps are there to help you to identify which parameters are required for the simulation. You can change and adjust them easily. And when it's done, then you can execute the simulation right after it. It's executing fast, independently from the setup, what you defined. If you have any mistakes or some data errors or something like this, there are warnings and error notifications which can help you to identify where the problems are and how you can correct it. And then at the end, you will have a clear overview about the simulation results. So our main target was that to create such a tool which you can use fast to evaluate your product. So it's around 1 minute to set the parameters, then it's execute fast, the simulation, and you will have an overview about the results at the end. If you have some special requirements, we offer any additional features with which you can evaluate this kind of stuff. So you have to open, of course, from our website, the required product. Now we are looking for a SIG-based half-bridge. When the product is open in the simulation environment, you can define, for example, your own custom heatsink definition. You have to put in your Foster model in the software easily, and then this takes effect over the fixed heatsink temperature. So this is calculated in the background. If some problems are with the convergences, you can adjust later the simulation engine as well, so the convergence criteria can be defined. And then you can configure, of course, again, your half-bridge. Here you see 3 different operation modes. So basic DC-DC and the DC-AC operation. If you have any question, then you can open the help for it. The steps are the same. You set the parameters, select the proper options, and then you will execute the simulation itself. Additionally, if you are interested, you can check the product characteristics. These characteristics are exactly the same what we have in our datasheet. They are fully correlated because they are derived from the common core where the measurements are put into the database, and we are query back these characteristics for the simulation execution. Let me raise some remarks. So the simulation software was released in the 1st of October last year. Since then, it is fully operated, no outage there. And we optimize for the commonly used web browsers. Additionally, we have materials for it. So we have a detailed user guide where the calculation core and the operation is described deeply. Also, you have basic introduction, short introduction videos, which can help you to use the software. And of course, because it is a web-based application, you can use your mobile phones and tablets as well to access product simulation. this kind of material can be accessed from our website. So below the VINcoTech website, there is the support documents submenu, and you can go to the simulation environment description. Additionally, we are planning to introduce new stuff into our simulation environment. So we want to enhance the user profile management and the simulation speed. So we want to add some flexibility to you to save and load your configurations and so on. We are planning to have more application-specific solutions to by integrating the mission profile simulation and introducing new operation modes and modulation methods. And finally, if you are curious about the whole performance, the whole characteristics of our power module, we will be able to perform parameter sweeping, with which you can find fast the optimum operation point of our products. And of course, we are continuously integrating our new power modules with which we will cover our complete portfolio, so every product will be able to be simulated in our environment. So as a summation, I would like to highlight that we have a high quality characterization with high performance measurement systems, and we have the generalized data modeling behind it. We support new topologies and products, so because of this general modeling description behind, we can easily integrate new topologies and products. We can help to support you in the decision making, so we put high importance on the user experience and on the UI design in the software to have a clear overview about your results. And also, if you have some special requirements, we support that also with flexible additional configuration and simulation options. Finally, this is a future-proof architecture, so the features what I mentioned you before can be easily integrated and introduced in that layout what we already figured out during the UI description process. So thank you for your attention, and if you have any questions, I am happy to answer, or you can visit our VINcoTech booth at Hall 7. Thank you very much.